Next in our analysis of infinite limits, we want to be able to analyze them analytically. And basically, you're going to have an infinite limit as x approaches a number. When it simplifies, you get a non-zero in the numerator and a 0 in the denominator as if you were to substitute in for that limit. There's only 3 possible answers in one of these cases, and those 3 possible answers for the limit as x approaches that number that causes this situation is either positive infinity, negative infinity, or that the limit does not exist. The way you can tell if it approaches positive infinity is you check the left and the right hand limits very, very close to whatever this number is, and if you end up with a positive and a number that's approaching 0 from the positive side, or a negative and a number approaching 0 from the negative side, you would end up with a positive. Similarly, if the two signs are different as you approach the asymptote from the side, then it would be negative. And then if approaching from the two different sides, if you end up with a positive on one side and negative on the other, then the overall limit will not exist. So let's look at the first example. I want to know the limit as x approaches 3. I'm going to get a vertical asymptote because simplified I still have a linear term in the denominator. So I need to analyze it as x approaches 3 from the left and the limit as x approaches 3 from the right. Notice when I put a 3 in here, I get a 0 in the denominator. And now let's see what happens if I approach 3 from the left. Approaching 3 from the left is like 2.99. So if I analyze the numerator, 5 times a positive number is negative 15, about. 2 minus 15 is a negative number. That's all I really care about, that I have a negative here. Now let's see what I get if I put 2.99 here. 2.99 minus 3 is a negative number. So I end up with a negative over a negative. A negative over a negative is a positive, so this approaches positive infinity from the left. So I write positive infinity. Same sign analysis approaching from the right. This is still going to approach a negative number. Approaching from the right, that would be like a number of 3.1. 3.1 minus 3 is a positive number. I get a negative over a positive, which is a negative, so I would write down negative infinity. Now, the overall limit as x approaches this vertical asymptote, I got an infinity and a negative infinity, so I would write it does not exist because these two are different. The first step you want to do when you're analyzing limits as you're approaching vertical asymptotes is you want to get it in factored form. If it's not in factored form already, get it in factored form so that you could do some analysis. Okay. I'm approaching negative 4, which we see is going to be a vertical asymptote because that gives me the 0 in the denominator. So this is going to give me some number over 0. And now let's analyze it from both sides. The limit as x approaches negative 4 from the left. Put a negative 4 in here. Negative 4 minus 2 is a negative. Negative 4 minus 3 is a negative. A negative times a negative is a positive in the numerator. And if I'm approaching negative 4 from the left, that would be like negative 5. Just think about it that way. Negative 5, that's a negative. Negative 5 plus 4 is a negative. A negative times a negative is a positive, and that would give me positive infinity for that side. The limit as x approaches negative 4 from the right, the numerator has the same analysis. But instead of putting negative 5 in, let's put a number to the right of negative 4. For example, negative 3. Negative 3 for x would be a negative. Negative 3 plus 4 is a positive. A negative times a positive is a negative. A positive divided by a negative is a negative, so I would get negative infinity. And I have a positive infinity and a negative infinity, so that this limit, two-sided limit, does not exist. I'll tell you that this actually helps me because this helps me graph the function, because I could actually graph it as it approaches from the left, it would approach that direction, and if it approaches from the right, it would go that way. So it does help you, even though we have a limit that does not exist, it does help us when we want to graph a function. Well, the last one I'm going to do is the limit as x approaches 3. If I put a 3 in here, I get 3 minus 3, which is 0 squared, so that gives me the 0. And then 9 minus 12 plus 3. Well, that's a 0 also. But I said we had to have a non-zero over 0 in order to do this analysis. So let's factor the numerator and see if we can get rid of that 0 over 0. This would factor two numbers that multiply to positive 3 that add to negative 4 would be x minus 1 times x minus 3 over x minus 3 times x minus 3. Notice that in factored form, I have a common x minus 3 that would cancel, which would lead me to the limit as x approaches 3 of x minus 1 over x minus 3. Now if I put a 3 in, I get 3 minus 1, which is 2, over 0, and I can now use this analytical analysis. So we need two limits. The limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. And we are going to analyze this function. And what we get is we get 2 minus 1, which is what? 2 minus 1 is positive. And then we approach from the left, so that would be like negative 4. Negative 4 minus 3 is a negative, which gives me a negative number. The next thing I have is the limit as x approaches 3 from the right. I get 3 minus 1, which is a positive. And then I get like 3.1 minus 3, which is a negative, which results into a negative. So this one, let's try this again. If I approach from here, that would be 2 minus 3. If I approach from here, that would be 4 minus 3, which is a positive, which is a positive. Negative infinity, positive infinity. So overall, my limit, again, does not exist. So you're going to ask, well, when does the limit exist? Well, the limit is going to exist. Basically, if you end up with an even power of something that's going to 0 in the denominator after you simplify, the limit will exist. It'll approach from the left-hand side and the right-hand side at the same time. Some students look at this and say, hey, well, it's an even power, so it's got to exist here. But no, it's the even power after you simplify that's going to make the limit, the infinite limit, exist.